All right, question 39. Trapezoid ABCD is graphed in the standard coordinate plane below. What is the slope from point C to point D? So first off, I notice it is a negative slope because we are going downhill from left to right. So right off the bat, we know it's none of these three. But the slope formula is y2 minus y1 over x2 minus x1. Doesn't matter which one is your x1, y1 and which one is your x2, y2, but we'll label them that way. So then the setup would be 1 minus 4 over 12 minus 9. So that's negative 3 over 3, which reduces to negative 1. When ABCD is reflected over the y-axis to a new ABCD, A prime, B prime, C prime, D prime, what are the coordinates of D? Well, really, let's only focus on point D then. So if we're taking this point and reflecting it over the y-axis, so this is our reflecting mirror, think about how far do we have to go to even get to that reflection line. Well, that's 12 units away. We know that because the x-coordinate is 12. So that means the reflection, we don't have enough space here, but the reflection is going to be 12 units in the other direction. The y-coordinate never changes, so it should be negative 12, positive 1 for number 40. 41, which of the following vertical lines cuts ABCD into two trapezoids with equal areas? So visually, it would be helpful if we had some grid lines down here at the bottom, at least for me. So this is obviously 2 out. This is about 9. This is 12. And then point B is 3. So let's just work this backwards. Let's start with choice A. These are all vertical lines. So the first one is at x equals 2.5. X equals 2.5 is here. So if we draw a vertical line straight up, does that divide the trapezoid into two trapezoids with equal areas? No way. 3.5, we can go and mark that one off as well because we're not moving over to the right far enough. Let's check out 4.5. So 4.5 is going to be somewhere right around here. Getting closer, but I still think we're off just a little bit. So it's either 5.5 or 6.5. We've narrowed it down to two choices once again. All right, so let's check out x equals 5.5. We don't have to draw this perfectly, but 5.5 would be roughly right here. So it's going to intersect these points here and these points here. So we're going to use the area of the trapezoid formula. So the formula is 1/2 times the height times the sum of the two bases. So let's calculate the area for the left side and the right side. Let's start with this left trapezoid that we've cut into with that red vertical line. So the height should be the same for both the left and the right trapezoid. So the height is just going to be the difference between the y-coordinates here. And the y-coordinate here is 4, and the y-coordinate here is 1. Same thing with these points over here. It's 4 and it's 1, so the height is 3. The length of the bases requires a little bit more investigating here. So the bases are the parallel bases. So what's this length? This length is the distance between the x-coordinates. So the distance between 2, remember this x-coordinate is 5.5. So the distance between 2 and 5.5 is 3.5. Up here, the x-coordinate is 3. This x-coordinate is 5.5. That distance is 2.5. We're going to calculate the area. So that's 1/2 times 3 times 6, and that's equal to 9. So now let's check the right side now. I'll do it over here. Again, the height is the same. The height is 3. The length of the base is the distance from 5.5 to 9. Well, 9 minus 5.5 is 3.5. Down here at the bottom, the base is the distance between 12 and 5.5. 12 minus 5.5 is 6.5. So this is 1/2 times 3 times 10, which equals 15. So those do not match. So it would not be D. Process elimination, it has to be E. (42) Composition of functions. So we've got our two functions. We've got f of x and we've got g of x. Here we are taking 1/2 and inserting it into the g function first. So we need to find g of 1/2, which is going to equal 1 divided by 1/2. When we're dividing fractions, remember you're just multiplying by the reciprocal. So 1 times 2/1 is just 2. This is the halfway answer. And now we're going to take 2 and we're going to insert it in for x in both of these places. We need to find f of 2. So that's going to equal 2 minus 1/2. 2 minus 1/2 is 3/2, 1.5. Then finally, number 43. Problem like this, again, I like to make up numbers. So let's make up numbers for a, r, and y. Let's say a is 2. It does say r has to be expressed as a decimal. So let's pick an easy decimal for r. Let's call it 0.5. And y represents years, can be anything. Let's use 10. And we're going to take those numbers and we're going to insert them into the provided formula. P equals 1/2 times 2 times 0.5 times 10. All right, so let's try it out. On top, it's 0.5 times 2 times 0.5 times 10 plus 2. On the bottom, it's 12 times 10, which is 120. All right, do all that, and I get 0.058 for P. Now I need to repeat the process, but now we need to multiply the A value by 2. So we're basically just going to change that 2 to a 4. Handy trick in the calculator is we can hit second enter and just type right over those 2's and change them to 4's. And we get 0.1167. So P has obviously gotten bigger. But has it been divided by 2 or has it been multiplied by 2 or has it been multiplied by 4? Well, let's work it backwards. Let's divide that number by 2. Yeah, and we can see that we get 0.058. But be careful, because I just went backwards to check that. They want to know when A is multiplied by 2, what is the effect on P? Well, P gets doubled when we multiply the A value by 2. So even though we used division to check that answer, really what we did was we multiplied by 2 on 43.